All right, here we are with day 3 on log page 3, the transformations of functions. Today our objective is to look at the reflections to sketch graphs of functions. If we want to reflect a graph, what happens to the equation is we end up using a negative sign. Okay, so h of x equals the opposite of x squared. This is the mirror image or the reflection of the graph of f of x equals x squared over the x-axis. Notice, let me go back one. Notice that this negative sign is on the outside of the function. You apply the function first and then take the opposite. This is a reflection over the x-axis. So y equals the opposite of f of x. This is outside the function, so it is a vertical reflection. Anything that happens on the outside of the function affects the function vertically. A vertical reflection means it reflects over the x-axis. All right, next we're going to look at the picture of h of x equals the opposite of x squared. This is the mirror image or the reflection of the graph of f of x equals x squared over the x-axis. You can see the red one is x squared. The blue one is the opposite of x squared. Every y coordinate here is going to change from positive to negative. So 0, 0, 1, 1 becomes 1, negative 1. Okay, 2, 4 becomes 2, negative 4. This is outside the function, so it's a vertical reflection over the x-axis. So let's look at h of x equals the square root of the opposite of x. This is the mirror image or the reflection of the graph of h of x equals the square root of x. It's a reflection over the y-axis because it's the x, that is the radicand, has a negative in front of it that's inside the function. So y equals f of the opposite of x. The negative is on the inside of the function, so we take the opposite of x first and then apply the function. This is inside the function, so it's a horizontal reflection. It reflects from left to right, and that's over the y-axis. Reflections in the coordinate axes of the graph of y equals f of x are represented this way. Outside the function is a vertical change over the x-axis. It's a reflection over the x-axis. H of x equals the opposite of f of x. Inside the function is a horizontal change over the y-axis. It's a reflection over the y-axis. H of x equals f of the opposite of x. Let's look at reflecting the square root function. We must restrict the domain to exclude negative numbers inside the radical. We cannot take the square root of a negative number. For example, if I have g of x equals the opposite of the square root of x, then the domain has to be all numbers that are greater than or equal to 0, because this x right here cannot be positive. This x cannot be negative because we cannot take the square root of a negative number. But if I have h of x equals the square root of the opposite of x, then my x has to be less than or equal to 0, because this x has to be negative so that when I take the opposite of it, it becomes positive so that I can take the square root of a positive number. K of x equals the opposite of the square root of x plus 2. Well, this x now has to be greater than or equal to negative 2. Because if I have a number that is less than negative 2, like negative 3, then negative 3 plus 2 is going to give me a negative 1 right here, and I cannot take the square root of a negative number. The next thing that we're going to talk about is the order that we do transformations in. This is the order that tends to help us not to make mistakes. So I would recommend, highly recommend, that you do your stretches and compressions and reflections first, then do your vertical and horizontal shifts last. Okay, you don't have to do it in that order, but this is a suggested order so that you don't make mistakes. Stretches and compressions and reflections first, then vertical and horizontal shifts. So let's look at these two. I want you to take just a few minutes and describe these transformations and graph them. See what you can do with these.